All right, here's our next electricity lesson. So far, we've learned about the current and voltage loop rules for circuits in series, parallel, and in combination circuits. So the last piece of the puzzle is how to deal with resistance. And then we'll be able to completely solve a circuit for any of the three most common variables in an electrical circuit: voltage, current, and resistance. So the easiest type of resistance to calculate is a resistance in series, where you have, let's say in this case, three resistors, and we're trying to find the total resistance RT. RT is defined as the resistance felt by the source. And its formula is just RT equals R1 plus R2 plus R3. And again, that RT is what's felt by the source. So that seems simple enough. If I didn't even teach you this lesson and I said, how do you think we find the total resistance felt by the source? I'm sure most of you would put your hand up and say you just add up the individual resistances, which is exactly what you do. Now, you might wonder about the subscript T. How I don't actually know why they put a T, but it makes me think of total resistance, which is fine. You can think of it as that, the total resistance in the circuit. I also hear it termed as the equivalent resistance. So you may see if it says calculate the resistance felt by the source, this is what you're doing. If it says find the total resistance, this is what you're doing. If it says find the equivalent resistance, this is what you are doing. And then I'm just going to skip ahead of this. And that, and here we go. Our first example is just calculate the equivalent resistance if I have resistances of 5, 4, and 3, and the other keyword there is in series. That means all in the same path. So I'm going to draw that really quick. It's going to look kind of ugly because I'm drawing on a computer screen, but here we go. So I've got a 5 ohm resistor, a 4 ohm resistor, and a 3 ohm resistor all in series. You're just going to have to humor me here and write it out. I know you'll know already that, okay, we just add those things up, but I do want you to show a little bit of work: 5 ohms plus 4 ohms plus 3 ohms. And that way I can at least give you part marks if for some reason you screw this up. 5 and 4 is 9 plus 3 is 12 ohms of resistance. So that should be nice and easy. Use a calculator if you want to. And then make sure you don't miss out on this very last statement here. The equivalent resistance or total resistance in series is always greater than the individual resistors. Now, you might think, oh, I don't need that. That's pretty obvious. Because, of course, if you're adding them up, it's going to equal more. But I want you to write it anyway, because you're going to find that when we do it in parallel, we get the exact opposite effect. So pause the video, at any time if I'm going too fast, so that you can write that stuff down. Resistors in parallel, it looks similar, but if we've got an R1 and R2 and an R3, then we have a slightly different formula, right? They're the reciprocals. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. If you're not very good at math, you might think, well, that's just the same thing. You're just putting it over underneath 1. It's not the same thing, and we'll add the same 3 resistors together in a moment here to show you that it's not the same. So if we have a resistance of 5, 4, and 3 now in parallel, I'm going to draw that out just because I need practice drawing these on the screen. Oh, that looks pretty ugly. Let's do that again. Still ugly, but good enough. There's my 3 resistors. It's 5 ohms, 4 ohms, 3 ohms. And I'm going to add those now in parallel. So I go 1 over RT equals 1 over 5 plus 1 over 4 plus 1 over 3. Now, if you're really like using common denominators to add fractions, you could do that here, but that's pretty time consuming. Here's exactly what I type into my calculator when I'm doing this is I type in 1 divided by 5 plus 1 divided by 4 plus 1 divided by 3, and then I hit equals. I'll pause here for a few seconds and give you a chance. It should be a decimal number for you. 0 decimal something. 1 divided by 5 plus 1 divided by 4 plus 1 divided by 3. Go ahead, pause the video if you need to, punch it into your calculator, and if at the end you get 0 decimal 783 repeating, then you have done that correctly. Now, that is not the answer to this question, though, because RT is what we're trying to find, and we just solved for 1 over RT is 0.783. So there's one more step to do on your calculator. You have to find this button. It should look like on my calculator, for example, it is x to the power of -1. I've also seen it as 1 over x. So look for those buttons. Usually it's a second function, right? But you do that, and then you hit equals one more time, and that will solve for RT for you. And in this case, it's 1.276 and a bunch of other decimals, but we would round that to 1.3 ohms. We circle that. That is the answer to this problem. If you struggled to follow that, you couldn't go quick enough or whatever, go back to the start of this slide, try and punch it in again. And everybody's calculator might be a little bit different, but this method of punching it in should work on just about every calculator to get the 0.783. And then it's just a matter of figuring out how quirky your calculator is to get the 1.3, which is the answer to this problem. Really what you're doing there, if you want to know, it is just a button on your calculator, but what you're doing is you're swapping the RT and the 0.783. So RT is actually equal to 1 over 0.783. So if you're really struggling, you could actually just punch that into your calculator and just type in 1 divided by 0.783. You'll be off by just a little bit because that 3 is repeating on my calculator, and I kept it on my calculator. But it should still round to 1.3. You should still get the right answer on any sort of assessment, okay? And now I'm going to erase a little bit here because I've gone over this next statement. And you may or may not have noticed already that the total resistance for these parallel resistors was 1.3, which is less than any of the individuals. We had a 5, a 4, and a 3 in parallel, and our total resistance was 1.3. And the more resistors you add, no matter how high the resistance is, your total resistance will always be less as long as you keep adding pathways for those electrons, those coulombs of charge to flow, the current to flow. The more pathways you add, even if they're highly resistive, the less total resistance you're going to have. That's the way that they work in parallel. Okay, so that one's a little trickier, takes a little bit of practice. But finally, we work our way up to this. Total resistance, equivalent resistance for resistors in combination. Remember, combination circuits have some parts in parallel and some parts in series. These things usually flow pretty well as long as you can identify where to start, right? So in this particular one, and it just takes practice, I can see clearly that the 3 ohm and the 2 ohm resistor are in series with each other. They're in series is because they're in the same path and there's no other resistors in that path. So the 3 and the 2 are in their own path together, so they are in series. So I'm going to say that the resistance for that 3 and 2 is equal to 3 ohms plus 2 ohms. Now, I wouldn't really expect you to show your work here. I think you can add 3 and 2 and it would make 5 ohms. All right, so instead of having a 3 ohm and a 2 ohm resistor there, I've taken this circuit and I have changed it so that there's only 2 resistances. I've still got this 4 ohm resistor here. I haven't touched it, but I've taken the 3 and the 2 and I've made it into one resistance of 5 ohms. this is what the circuit looks like now. This is a process called circuit reduction in senior physics and electrical engineering and all that stuff. So now you can probably see, oh, now I have a 4 ohm and a 5 ohm resistor in parallel because they're in different paths. So to finish this problem off, to get the total resistance in the circuit, I got to go 1 over RT is equal to 1 over 4 ohms plus 1 over 5 ohms. Again, on your calculator, just like before, type in 1 divided by 4 plus 1 divided by 5, then hit equals. It'll give you 0 decimal something. And my calculator gives me 0 decimal 45. You might think you're done, but you're not quite done. You got to find that x to the power -1 button or the 1 over x button. They do the same thing. Hit that. I'm doing it right now. And pause the video if you want to take a stab at it and see if you get it right. And you'll find that total resistance is 2.2 ohms. I rounded that off. It was actually 2.2 repeat on my calculator. This is about as hard as it gets, guys. This is about as hard as it gets. If I was doing the solution myself, I'll just show you a bit of once you're good at this, a lazier way to come up with the answer. Instead of drawing the circuit out and redrawing it out, if there's a couple of resistors that are very easy to add in series with each other, usually what I do is I just circle them and I put a great big 5 over top of them, because 3 and 2 made 5. And then I can just see that I've got my 4 and my 5 in parallel. And then the only work that I show is that 1 over RT equals 1 over 4 plus 1 over 5. I punch it all into my calculator, and then I get 2.2 ohms. That's at a bare minimum, this is the amount of work I would expect to see. And then I'd expect to see you drawing on that diagram. All right. So that's, once you're really good at it, just a little shortcut that you can take. You have to write less, but the rest of this lesson is just solving a few more combination circuits. So here's our second combination circuit. Right away, I can see I got to identify 2 that are either in parallel with each other or in series with each other. I can see that the 4 and the 5 are most definitely in parallel with each other. Now, I could just punch that into my calculator, but the parallel ones are a little trickier. So I'm going to write 1 over R equals 1 over 4 plus 1 over 5. Follow the same steps that we did on the last slide. And just because we just added a 4 and a 5 in parallel, I know that the total resistance for those 2 is going to be 2.2 ohms, as long as I did it right on the last question. So I'm going to draw this out again. And I suggest until you're real good at this, you do the same thing. So what I did is I didn't touch the 3 ohm resistor. I didn't touch the 2 ohm resistor. I took the 4 and the 5 and I made it into a total of 2.2. And the reason we draw those out when we're just starting these is because now it's very easy to see that these 3 resistances are all in series with each other. So then I just put the 2, the 3, and the 2.2 together. I'll show my work for it, although I know that this is easy just to do in your head, really. So I got a 2 ohm resistor plus a 2.2 ohm resistor plus a 3 ohm resistor. And that's going to add up to 7.2 ohms. 2 and 3 is 5. Yeah, 7.2. I think I can circle that and I'm done. Next one, another combination circuit. It's actually very, very similar to the one we just did, not numerically, but in the setup, in that I can see right away that I've got a 4 ohm resistor and a 3 ohm resistor in parallel. Now, I suggest you pause this video as you go, because you're going to want to draw this circuit into your notes. And I'm just throwing it up on the screen and I'm starting to solve it. If we were doing this in class, I would wait here for a minute or two for you guys to draw these. You guys just pause the video, draw the circuit, and then away we go. So on that one, I feel like I should show my work. 1 over 4 plus 1 over 3. And just like before, what you're typing into your calculator is 1 divided by 4 plus 1 divided by 3 equals, and it gives me 0.583 repeat. I'm hitting that inverse, that x to the -1 button on my calculator, and it gives me 1.7 ohms. I'm going to redraw this circuit because some of you still should be doing that. I've got 1 resistance there. I've put those two together now, and now I've just got three resistances in series. I've got a 2 ohm resistance here, a 5 ohm resistance here. I've taken the 4 and the 3 and made 1.7 ohms. Then to find my total resistance in this circuit, it's just a 5 ohm resistor, a 2 ohm resistor, and a 1.7 ohm resistor. 5 and 2 is 7, plus 1.7 is 8.7 ohms. You can do that on your calculator if you need to. Now, if this seems tricky, that's good. That's because this takes practice. But you should take some comfort in this is as hard as it gets. These are the toughest one you're going to be asked to solve in this particular course. The last example I'm going to do is a little different than the other two. It's still a combination circuit. The first thing I notice is that I've got a 4 and a 5 in series. They're in their own path. They're in series with each other. So the 4 and the 5 make 9. And I'm taking the easy way out here and just putting that 9 there. I guess I can redraw that circuit for you. I'll have a couple of redrawings in this one then. So I have a resistance here, and then I took the 4 and the 5 and made one resistance there. Maybe I'll redraw that arm there. One resistance here. So that made 9. This is a 4, and this is a 2. Now what do we have? I can see clearly that the 4 and 9 are in parallel with each other. So I'll show that work down here. I write 1 over R equals 1 over 4 plus 1 over 9. In my calculator that I'm picking up right now, I type in 1 divided by 4 plus 1 divided by 9. It gives me 0.36 and 1 repeat. That's not the answer. That's not what those two are in parallel. I still have to hit that x to the negative 1 button and then hit equals again, which is going to leave me with an equivalent resistance in that spot of 2.8. I'm going to write it as I rounded that off. If you're wondering, on my calculator it says 2.769230769. I rounded it to 2.8. I'm still not quite done yet. I'm going to redraw this one more time. You guys don't have to keep redrawing these over and over, but just to show you where we're at. I've taken the 4 and the 9 and turned it into one resistance. So now I've got a 2 ohm resistance still at the top, haven't touched it yet. I took the 4 and the 9 and made it into a resistance of 2.8. Now it's really easy to finish off. Total resistance is just 2.8. I could probably make a nicer 8 than that. 2.8 ohms plus 2 ohms, which is 4.8 ohms. All right. So those last three are about as tricky as it gets. Combination circuits are as hard as this stuff will get for you. I did post some practice with this stuff. Just give me a friendly reminder, a message on Classroom or through my email. If I forget to put the answers to that practice, then just ask for it. Or if you get stuck on one, just ask for it. And we'll take it from there, all right? That should be all for now.